that surprise and sudden unexpected events is actually the way the planet operates. And this is coming as a surprise to many. You know, we've built up our economic system, our societies, in fact, very much of our relationship with planet Earth on the assumption that the atmosphere and the forests and the oceans and ecosystems and land kind of changes very slowly, almost irrespective of what we do to it. And the change may be good or bad, we recognize that, but it does change linearly. And it does change very slowly. And it does therefore change in a predictable way and in a way that we can cost with money. We can even say, well, if you destroy some trees there, you have to pay because that's kind of the discount rate in 20 years, and that's what we call the value of changing nature. And I can tell you, science now shows clearly that it's exactly the reverse. Nature does not behave linearly, incrementally, and in predictable ways. Oh no, nature is surprise. Nature behaves in a surprising way. And the way nature does this is actually lulling us into a comfort zone, which is a bit tricky, but also humbling. What happens with nature is that we can kind of abuse nature, like we abuse the climate or cut down trees, and we can do that during a very long period of time with very little change. And that's what we call resilience. That is just like us humans. You know, if you're healthy, you can take a bump, you can take a second bump, you can take a third bump, you can even take, you know, some rough time, but then at a certain point, pang, you'll tip over and you'll fall into bed. And the same thing goes for a rainforest or a lake or a coral reef. It can take environmental change to a certain point, but then a small shift can actually push it across a tipping point, and the whole system can actually flip over rapidly. And when it does so, it changes state and can abruptly shift in two ways. One is that it no longer delivers to our human well-being. You know, if a forest disappears and becomes a desert, it cannot deliver to our human well-being, neither for those who live in the forest nor for us who depend on timber and food. But the second thing, which is the most important thing, is that when a big ecosystem tips over and no longer is where it was in the Holocene, it is very likely to change what we call its feedbacks, and it can go from being our best friend, where it kind of reduces the impacts, for example, of climate change, like you can have the ocean taking up carbon dioxide, helping us to reduce the impacts of climate change. But then if the ocean tips over a tipping point, it could actually start releasing carbon dioxide and become a self-reinforcing negative foe, which could actually accelerate change in the wrong direction. This is what we scientists call tipping points. This is the sole thing that keeps scientists awake at night. There's nothing that makes us more nervous than tipping points that could lead from things working as a friend to changing into a foe. Do we know these systems today? Yes, increasingly we do. And this is the biggest threat to humanity, but also why we need to stay within safe boundaries for all these environmental parts. Now I'll be showing you a few examples of these tipping points. The first one came actually as a signal in May 2014. 2014, scientists showed from observations that the Thwaites Glacier in Antarctica, from the Antarctic, West Antarctic ice shelf, is irreversibly sliding into the ocean. Now, we had never expected that. It's a complete surprise because Antarctica has always been thought of as being very resilient, being able to take some little climate change, but never, ever changing. In fact, the view has actually been that Antarctica is so cold, it stays stable all the time. But to everyone's surprise, the ocean is so resilient because it takes up 90% of the heat caused by our emission of greenhouse gases, and it sucks it down into the deep ocean, but then it wells up to the surface, and what comes to Antarctica is therefore warmer surface water, which is wettening and lubricating from below the ice sheets. And ice sheets on Antarctica, you should be aware, is enormous slabs of ice standing on rock. But you know, this rock, if it gets warm water from below, gets lubricated, and then to a certain point, after just buffering and buffering and buffering, it tips over, crossing a tipping point, and it starts sliding irreversibly. And the Thwaites Glacier started sliding, and the estimates show that once that glacier starts sliding, it's like taking a plug away from a bottle. You know, you lose a plug, and then suddenly things start falling from upstream. So this is the plug that holds all the glaciers upstream on land. So now we're seeing a situation which is irreversible of glaciers sliding into the Amundsen Sea in the Antarctic Ocean. This is the first example of us inducing a tipping point already at 1 degree Celsius warming, which will irreversibly commit ourselves to something up to another 1 meter sea level rise over the next 200-300 years. It may sound as a long period, but it really is ethically a very short period. So these are the kind of tipping points that we cannot accept. And this is just one example of something like this happening. And just to put this in perspective, just so you're aware of what we're talking about, you know, if we would burn the remaining known reserves of oil, coal, and natural gas, we would actually commit the world, our world, to 58 meters sea level rise. So it's not a small thing. Greenland holds 7 meters sea level rise. The Antarctica holds another something like 50 meters sea level rise. And then we have the expansion of the oceans. So we're talking about very, very big changes that can be induced if we allow ourselves to do things in the wrong way. And this is what really needs to change in terms of our behavior. Now, as you see here, this is ice. This is ice in its, so to say, stable state. And what is so important with ice when it comes to understanding this complexity of feedbacks is that this is a white surface. Can you believe it? The color of the planet is the most important friend we have, but could also become a foe when it comes to staying in the Holocene. So we know now with very good precision that a key reason why we're in the Holocene is that we have the Arctic and Antarctica as permanent ice sheets on the top and bottom of the planet. These are like cold cooling hats on the planet, and they are decisive to keep the Holocene in place. So we can say that we depend, all of us, on having permanent ice sheets in the North Pole and the South Pole. Now, why is that so? Well, it is simply so because when you have a white surface, the sun, sends its heat to the planet Earth in form of shortwave radiation, and a white surface will reflect in the order of 90% of that incoming heat. So the polar regions are white surfaces that are like cooling systems for the entire planet. And we know now that the reason why we have a Holocene state is that these ice sheets are permanent. And what happens is that once you have a permanent white ice sheet, is that it can cool itself, the ice grows, and then it finally finds an equilibrium, and it has found an equilibrium which is the exact ice sheets we have on planet Earth. What happens now is that we're melting the ice. So when we're melting the Arctic and Antarctic ice, what happens is that the planet becomes darker. And when it becomes darker, what happens then is that more solar radiation is sucked up by the planet, which means that the planet starts self-warming itself because it changes color from a permanent ice sheet, a white color, to a liquid surface which is slightly darker. And I can just share with you that the first signs of this are starting to become visible. Greenland, a huge permanent ice sheet, actually for the first time ever was entirely melting in 2012. So 2012, for the first time, it went from a white surface to a slightly darker liquid surface. It melted for only 2 weeks. Then it bounced back. So it's still resilient. It still seems to have the capacity to not cross a tipping point. But scientists observed something really important. Those 2 weeks, for only 2 weeks, the Greenland ice sheet was a permanent liquid surface because it was all melting. And just that slightly darker color, from white ice to dark blue water, meant that the planet absorbed in the order of another 200 exajoules of heat from incoming solar radiation because the reflectivity reduced so much that Greenland went from being a cooler to becoming a self-warmer. Now, 200 exajoules says nothing to neither me nor you, but one way to understand it is that the United States consumes 200 exajoules of energy over an entire year. The world consumes 600 exajoules. So little Denmark suddenly bypasses momentarily both China and the US as the world's largest climate, impacting nation. Not because the Danes emit so much greenhouse gases, but because Mother Earth changed that feedback on Greenland. So this is really an important insight, that we cannot avoid the insight that surprise is an integral part of how the planet works. Okay? So that's insight 3. And this is then what gives us the final story.